This is Cycle 1, Week 18, experiment number 140 in Van Cleve's book, Push Up. The purpose of this experiment is for the students to see some practical demonstrations of air pressure at work. I would start the lesson with an introduction that says, God created this world that we live in, and He created it in many wonderful and different ways. One of the things that God did was He created places of dry land, and He created the oceans and the seas and the rivers. He created places of water. I have some water here in this cup. Water is the most abundant liquid on our planet, so it's one that we are very familiar with. Because this water is a liquid, and it is so familiar to us, it's the best example of a fluid. A fluid is something that has very specific science properties. One of those properties that it has is pressure. Fluids exert pressure, and we have some practical experience with that. So I would ask the question, who here has been swimming? Who here has been swimming? So what happens when you put on your goggles and you dive into the deep end of the pool and you hover with your body as close to the bottom of the pool as you can? First off, that's awesome and that's cool. But secondly, we experience a change. We feel something different in our ears, right? Who knows? What do you feel? You feel something literally pushing on your ears. What you're feeling is the pressure that the water is exerting on your body. Because at the bottom of the surface of the pool, the pressure is greater than it is at the top. You feel that pressure that the water is exerting, and we feel it in our ears because God made our ears that as very wonderful instruments that are extremely sensitive to minute changes in pressure. And so when we dive into a 6-foot deep pool, we feel it in our ears. What about an airplane? Who here has ridden on an airplane? So when we take off in an airplane, a lot of times our ears pop. We say when we land, we experience the same sensation. Sometimes even at cruising altitude, we'll experience a pop in our ears, as we say. That again is a sudden change in pressure. It's literally an equilibration of the pressure inside the eardrum with the pressure on the outside. Because as the plane goes up in the atmosphere, there's less air pressure pushing on our eardrums. That's literally what's happening. And so while I think it's easy for us to understand that a liquid like water, which is really a fluid, has pressure, it's a little bit harder for us to understand that the air around us, that the atmosphere with all of that mix of gases, those are also a fluid that exerts pressure, and it's the pressure that we call air pressure. So with that practical demonstration then, with that introduction, I would move into the practical demonstration, and I would start with a little bit of a bonus experiment. I would start with this. I have here a sippy cup. This will be especially good for the younger CC students. So in my sippy cup, I have a fluid. I have water. I have another fluid here in this sippy cup. What is it? Who knows? Ask the question. What other fluid is there? Start with what fluid is here. I think they'll immediately say water. What other fluid is here? It may take a little bit of leading. You may just have to tell the younger students it's air. Right on the surface of this water, because the water doesn't come all the way up to the rim, there is air. Think of it as a layer of air. So we have two fluids here. We have the air and we have the water. And so then when I take my sippy cup lid with a straw, in this case, and when I close the lid, I then can demonstrate what will happen when I change the pressure inside this container. So we have the pressure of the water, we have the air pressure that's sitting on top. The lid is not touching the water directly, but it is touching the air. And that is what is so important. So when I seal the container, and if I do it quickly, especially, I can have a very dramatic effect like this. Watch. So that's cool. That's fun. Who doesn't enjoy that? But what's happening again? I was able to shoot the water out of the cup. Why? By pushing down on the lid, did the lid touch the water itself? No, but it's touching that fluid of air that's sitting on top of the fluid of water. And so the whole system then is those two fluids stacked together. And so then when I suddenly change the pressure by closing it and pushing down, I'm creating high pressure inside. And so the entire system then is seeking an outlet for that pressure, and the outlet is back out through this straw and so the liquid comes out. Now, as a practical point, you can get a similar effect if you just if the liquid level is high enough and you just close the lid, you can get the water to come out, but that's not nearly as cool as what I just did. So I would do it that way. I would do it with some drama. Okay, so that's one bonus experiment where we see a little bit of the effect of air pressure. As I increase the pressure inside, I'm able to shoot the liquid out. Okay, so then I would get my big bowl of water. I'd have the students get pretty close, actually, for this experiment. If you've got really grabby students, that's something to think about for sure, but they really need to be close so that they can see it. So I'll take my sippy cup, I pour the water back in. So I would say, now, here's my second demonstration. So I have here a big bowl. What is inside this bowl? Water, the students will say. Exactly. Is that water a fluid? I hope they will say yes, but if they don't, you tell them. Yes, it is. What I have in here, I have this water fluid here in the bowl. So what happens if I take this cup and I put it in the water, not going straight down, but what happens if I put it in at an angle? What's going to happen? The water is going to fill the cup, and especially the older kids will come up with that pretty quickly. But it's a good demonstration, so everyone watch. So I put the water in, you can literally see the water filling the cup. And so then for this week's experiment, I'm going to take the cup all the way underwater, submerge it completely under the liquid level, and I'm going to tilt it just slightly and bump it once so that I have as much of the air bubbles removed as I can. And then I turn the cup upside down. So the cup is sitting in here, and now I'm going to say, so what is inside this cup? Right now there's water sitting inside that cup. What happens if I pick this cup up? Is the water going to rush out and go back into the bowl? It's a question you need to help them to think about. Logically, a lot of people would say, yes, it will, but we see something different. Watch. So, and that's why the students need to be close so that they can see it. So as I pick this cup up, as long as I keep the rim of this cup below the surface of the water, I have a cup that's filled with water. So gravity is pulling down on the water that's in the cup. The force of gravity is pulling down on the water that's in the cup, but yet the water stays inside the cup. Why? Because there's another force acting here in our system, and that's the force of the air pressure. The air pressure is pushing on the surface of this liquid. There's nowhere else for this liquid to go. It's a closed container, and so when I make this cup a part of that system, then I'm able to actually pull it up just like this and expand, and the force of the air pressure is enough that it will keep this cup filled with water. The force of air pressure at sea level is 14.7 pounds per square inch, so about 15 pounds per square inch. I would tell my students, literally think of a 15-pound weight that's sitting on a 1 inch by 1 inch area. Maybe bring a 5-pound barbell and then point out to them that that's 5 pounds. Feel how heavy that is. Now imagine 3 of them stacked together. And now imagine that we could somehow change the shape so that all of that mass was sitting in a 1 by 1 area. That's how much pressure the air pressure is exerting. We can demonstrate it also with another cup. So now this is not a sippy cup. This is Old Spaghetti Factory cup. This is a cup from our BC days, before children, you understand. This cup is in a completely different shape. It has a completely different volume. I'm going to make this cup part of my system of the bowl in the exact same way. So I take it, I fill it up like that. You can probably hear the air escaping. So I submerge the liquid, submerge the cup completely under the glass, and now I can turn it up. You can already see that water is sitting inside that cup. So is the force of the air pressure pushing down enough to keep it in here as well? Well, let's see. So I can lift this cup up carefully. I keep it right below the surface. Yes, very, very clearly there's water inside that cup. In fact, the surface there's enough air pressure pushing down that, look, it will support both volumes, both masses of water inside that cup. And you can clearly and easily demonstrate it just like that. That's how I would do Cycle 1, Week 18, Experiment 140, push-up.